Jump into section 4.2, just do a couple of these questions real quick. This section is on the properties of expected value and variance. So the homework begins with a bit of a review on expected value. When you add the values of two variables, the mean of the sum is the sum of the individual means. Remember, expected value here is just another word for the mean. Okay, and same thing with the variance, that the variance of the sum is the sum of the individual variances. And then as a reminder, variance is just the square of standard deviation. So we're going to do this in Desmos, and we'll jump on over to there in just a moment. The commands in Desmos are mean of a list, where A is your list of values in square brackets here. You do the mean, the standard deviation. This is going to be a population standard deviation, so the command has a little p in it for population. And for the variance, you just square that. Okay. And so we're going to start with a population of values here, 4, 6, 6, and 8. And we'll get the mean and the variance real quick. So I'm just going to copy these and open up a window for Desmos. And we'll again put the list of values in A with square brackets like that. I think I can see the mean is just going to be 6. But we'll go ahead and ask for it. The mean of A is 6, you can see here. Standard deviation, I actually am not being asked for, but STDEV for a population standard deviation is this 1.4142, which looks like the square root of 2. So when we square that to get the variance, you can see the variance is just 2 here. Okay, so I think I can put in the mean is 6, the variance is 2. Let's pop back over. Oops, not here. Okay, so let me go to it. Here we go. The mean is the expected value, that's 6, and the variance was 2. So we should be able to get those right. Okay, now we have a new population of values that are called Y. So 3, 4, 4, 4, and 5. So I'm going to copy those and go back to Desmos. And I'll just overwrite what I did before. So A is now going to contain the Y values. You can see that the mean and the variance are just updated here. So the mean is 4 and the variance is 0.4. I think I can remember that. So 4 for the mean and 0.4 for the variance. Should be okay. All right, now we're going to do the X plus Y distribution here. And so that's all of the X's, 4, 6, 6, and 8, plus every one of the Y's, 3, 4, 4, 4, and 5. So here you can see the X's, 4, 6, 6, and 8 in the top row. And then this column has the Y values. We're just adding. So every X plus every Y. 3 plus 4 is 7. 3 plus 6 is 9. We got 2 of those. 3 plus 8 is 11. Okay, now adding 4 plus 4, we get 8. 4 plus 6 is 10. Another 10. And 4 plus 8 is 12. The next 3 rows will be exactly the same. And then the last row, we're adding 5 to every one of the X values. So 5 and 4 is 9. 5 and 6 is 11. And 5 plus 8 is 13. Okay, so those are the values. Should be okay. Let me see. Yeah, I'm just kind of double checking everything here. Now, I need to key in all these values into Desmos to get the new mean and variance. Actually, they want us to make a frequency table. Okay, that's cool. So the 7 occurs just once up above. If you look for the 8, there's 3 only. Okay, the 9 occurs, let's see, 1, 2, 3. I only see 3 9s. Okay, the 10 occurs 1, 2, 3, 4, 5, 6 times. The 11 occurs 1, 2, and 3 times up there. The 12, there's 3 of those also. And the 13, I'm guessing, appears only 1 time. Yep. So those are good. Oh, I screwed up on my 7. I think I typed wrong, so that should have been a 1. Okay, so those are correct. And then here's a histogram nicely drawn. Obviously, this is symmetric and roughly bell-shaped. Now, this is important because if you go back to the original distributions, those were definitely symmetric and sort of roughly bell-shaped. And so the distribution of sums, x plus y, inherits that bell-shaped nature from the individual distributions. So that should be fine. And then we can very quickly, we can go in and type in all these values in Desmos that we had. That's a lot of them. I think I could do it cleverly. No, I don't think I can do it cleverly, actually. So I'd have to type them in individually. So I think I'll go ahead and do that. So real quickly, I am going to pull out my Desmos page and split it away from the other so I can see it all. Okay, so here's the homework. Here's Desmos. I'm going to make it kind of smallish. And then I'll delete these values I had and type in what I've got, 7, 9, 9, 11. Then 8, 10, 10, 12. And I think the 8, 10, 10, 12 occurs 3 times, so I'm going to copy and paste that. Then the last row, 9, 11, 11, and 13 is the last. Okay, so you can see we've got a mean of 10 and a variance of 2.4. So one of the things we know, though, from the homework is that way up above here, that the mean of the sum is the sum of the means. Where is that here? So the expected value is the mean. The mean of the sum is the sum of the individual means. So before, the means were 6 and 4. The sum of those means is 10. And then going back to Desmos real quick, the mean of the sum was 10 here. So that's kind of just validating everything. The mean of the sum is the sum of the means. The means are 6 and 4, so if you add them, you get 10. The variance of the sum is the sum of the variances. So the individual variances were 2 and 0.4, and in Desmos, remember, the variance is the standard deviation squared, and that was 2.4. So 2 plus 0.4 is 2.4. And then the standard deviation is the square root of the variance. So I'll just take square root of 2.4, and we get 1.549. Let's see how many places. 2 places. So I'll go 1.55 for the standard deviation. That should be okay to go. And that's it. Okay, so we're done with that question. Now, for the next question we're going to look at, I think I'll look at question 2, and we get a whole list of properties. This is for independent variables. We've already talked about expected value of the sum. Actually, yeah, the expected value of a sum is the sum of the expected values, and the expected value of a difference is the difference of the expected values. But for independent variables, the variance of the sum is the sum of the variances, and the variance of the differences is the sum of the individual variances. So we add variances whether we're adding or subtracting our variables. Okay, so just real quickly, we're going to zip through this. We're given that the mean of x is 7.2 and the mean of y is 3.4. The mean of x plus y, you should just add those. So that's the sum of the means. So you would do 7.2 plus 3.4 here. So let's do that over here. 7.2 plus 3.4 is 10.6. So that should be the mean. Okay, and then the variance of the sum is the sum of the variances up here. Variance of the sum is the sum of the variances. So the variances are 2.9 and 1.1. Okay, and of course that's 4, so we can just go ahead and put in a 4 there. And the standard deviation would be the square root of the variances. So if you do the square root of the variance, that was 4. So, and of course, oops. So square root of 4 is 2. And so that's the standard deviation. Okay. Now the mean for x minus y, this would be the expected value of x minus y, which is the expected value of x minus the expected value of y here. So if you take the expected value of x, that's 7.2. And then minus the expected value of y here, which is 3.4. So that's 3.8. That should be the mean of x minus y. Now, the variance of x minus y, remember the variance of x minus y is the variance of x plus the variance of y, which is the same as for x plus y. So if you look at the variance for x plus y, that was 4. And that will be the same here. It'll be 4, and the standard deviation is the square root of the variance, so that'll be 2 again. Okay, and pardon the dog. Then we have to talk about the mean of 3x, and the variance of 3x. So just taking a quick look, the variance of the mean of kx is k times the mean of x, or the expected value. Okay, so if we multiply all the values by 3, then the mean gets multiplied by 3, is what that says. So the mean of x up here was 7.2, and we're doing the mean of 3x, so we would just do 3 times 7.2, like that, 21.6. Now, the variance of 3x would be, if you look at the formula here, the variance of kx is k squared times the variance of x. So the variance of 3x would be 3 squared. Oops, let me clear that. So I'm doing 3 squared times the variance of x. And the variance of x up here was, I've got it written down somewhere, but right here, variance of x is 2.9. So we have to do 3 squared times 2.9. And so that's going to be pretty big, 26.1. Okay. And then the standard deviation, we just take the square root of the variance. So we'll take square root of, oops, that's wrong again. Square root of the variance, which was 26.1, which is 5.1088, and how much rounding? It says 2 places, so we'll say 5.11. Double checked everything, and it looks like we're good to go.